All right, today we're starting energy transfer. So far we've talked about just the definition of what type of energy it is, identifying it. So yesterday we talked about what 3 types of energy. Someone raise your hand. Tell me what 3 types. Give me one. Yes, sir.
Mechanical energy.
Mechanical energy. Who can give me a example of a mechanical energy? Yes. A roller coaster going up and down. Okay. Yes.
The mouth.
Your mouth when you're chewing. When's another example of mechanical energy within the body? Yes. Walking, okay. Yes. Your heart beating. But within your digestive system, where else is mechanical energy found? Yes. You want help? Okay, yes.
Like when the food is going through?
Yes. Like in your stomach, when your stomach is contracting, you have muscles that are causing it to be turned. Remember, it turns into chyme in the stomach. Also, when it's being pushed through the small and large intestines, those type of things, okay? But the main mechanical energy is in the mouth when you're chewing. What was another? So that's mechanical energy. What was another energy we talked about yesterday? Yes?
Thermal.
Thermal energy. Who can give me an example of thermal energy? Yes, Mason. Your stove when it heats up, okay? I have a gas stove, so like mine literally turns on a flame. And so in a fireplace, things like that. Okay, Alex?
When your forehead heats up when you get sick.
When you what?
Your forehead heats up when you get sick.
Okay, so that's because of a fever, but yes. So any kind of heat. Yes?
Your natural body heat.
Your natural body heat. Right now, you are having a transfer of thermal energy into one of 2 places. It's either going into your clothing or it's going into the air, right? Okay, that's your body's way of keeping you at the correct temperature. Now, what is that transfer when we're trying to make something and something else the same temperature? What is that called? Heat, right? Okay, that was our definition. What's the last type of energy we talked about yesterday? Yes, ma'am.
Chemical.
Chemical. Who can give me an example of chemical energy? Yes.
When you add like water to the seed and then it grows. Yes. Almost there.
Kind of. Okay, yes, sir. That's mechanical when you're chewing, but there was an example in the mouth that you could have given. Yes, Charlie? Yes, when the sun gives energy to plants. Well, no, that's the glucose that is made is the chemical energy. The sun itself giving it to the plant, that's radiant energy. Okay? Remember when we talked about chemical energy because of the saliva and things like that in our digestion? Okay? All right, so we're going to start off with the basics. Okay? Everything starts with the sun, right? It always starts with the sun because we always get some energy from the sun. And that starts through the process of photosynthesis, right? So plants take radiant energy from the sun. Take radiant energy from the sun and turn them into chemical energy, which is glucose. Okay? So you should be writing this down in your journal. The process of turning radiant to chemical energy is called photosynthesis. Okay? So you want to make sure that you have written down this part right here. Okay? And then you want to add to that, it's the process known as photosynthesis. Okay? Does that make sense? The process of that is called photosynthesis. Radiant to me makes sense that this would be sun energy because the sun radiates light, right? But this one is, please remember that this is light, not heat. That radiant energy means light. That's why even when it's cold, okay, I know not all plants can grow when it's cold, but some plants can. And it's because all plants need light. But some of them are based on temperature and some are not, right? Because if you just put a plant in some water and some soil in a warm place, it's not going to grow. It has to have that light to grow, right? Okay, the next part is that animals digest plants to take the chemical energy of glucose, right? So it doesn't matter what you eat, okay? Someone raise your hand and tell me what you ate for breakfast this morning. Yes, ma'am. Tell me what you... Cold pizza. Breakfast of champions. Okay? So, you ate... hold on. That's all I need. I just need that one example.
Well, be quiet.
All right. So, she eats the cold pizza, right? At some point, that pizza was a couple different things. At one point, it was grass. Okay, so here's how we get to cold pizza. The sun comes down, right, and it grows grass. The grass is eaten by the cow, and the cow gives us the milk to make cheese. Okay, we can also do this with the grain, okay, that makes the crust. So the sun comes down, the grain grows, we make the crust out of flour. That was the grain. Okay, so at some point we got it. So now we're chewing it up and we're eating it for breakfast. Okay, we good so far? We're taking the chemical energy out of it in the form of glucose, okay, and nutrients, right? So, yes, sir?
What about the pepperoni?
I don't actually know where a pepperoni comes from.
I'm reading a
I think that's sausage.
variety of salami.
We all have step 2 done and ready? Okay, let's go on to step 3. Okay, within our body, the chemical energy is transformed into mechanical energy and thermal. Pretty much anytime you turn chemical energy into something else, it's going to produce multiple types of energy. So for us, it turns into mechanical of us walking around, doing whatever that we're doing. But the byproduct of that, meaning the extra thing that comes from it, that process of us turning our mechanical energy or chemical energy into usable energy, that byproduct is that heat or thermal energy. Okay? And what type in our body, what type of energy does this turn into? Yes. What is the name of the energy that it turns into?
ATP.
ATP. And who can remember what ATP stands for? Yes.
Stands for. I thought you were going to say ATP is.
Anyone? Adenosine triphosphate. Okay, adenosine triphosphate. So, when we take a molecule of glucose and we break it down, it's going to make ATP for us to use as mechanical energy, but it's also going to produce carbon dioxide and thermal energy. Okay, do we need a certain amount of thermal energy all the time? Yes, because your body temperature has to stay at the right temperature. So that's a good byproduct of the ATP process, right? So, and of course we need to get rid of the carbon dioxide because if you don't, you'll get poisoning. We need one seat for the two of you. Thank you. All right. So, thermal energy. Obviously, our thermal energy sometimes goes up. The more active we are, the more thermal energy you have. That just makes sense, right? Okay.